Let's do some trigonometry. In fact, what we're going to do is we're going to study right triangle trigonometry. And let's start like this. Let's draw ourselves a right triangle. We'll draw this right triangle here, and that'll be our right angle. Let's label this angle A and this angle B, and this will be our right angle here. Now, opposite A over here, this is angle A. The side opposite A, I'm going to label that with a lowercase a, and the side opposite angle B, I'm going to put a lowercase b, and then for the hypotenuse, let's make that a c. Now, there are 6 trigonometric ratios. I've already written down parts of 3 of them. I've written down the sine, the cosine, and the tangent. And we'll get to the other ones soon. But let's make these definitions. So we're going to define what we mean by the sine of angle A. So it's a function that we're going to place on angle A. We're going to put angle A in and compute and get something back out. So what do we mean by the sine of A? Well, here's what it's going to be. It's defined to be this. Here's angle A. We define it to be the length of the side opposite divided by the length of the hypotenuse. So let's write that in terms of our A, B, and C. So it's the sine is the side opposite. Now here's angle A. The side opposite is that lowercase a. You know what? Let's even do that in red. This is going to be A over the hypotenuse. And the hypotenuse up here is C. So we'll write C. Now, the cosine we define like this. The cosine of angle A is the side adjacent to A over the hypotenuse. Now, it's the side adjacent over the hypotenuse. So look at angle A. Here's the side that's adjacent to A. That's B. So let's write a B over the hypotenuse. And the hypotenuse is C. Right? And then our third main trig function is the tangent of A. So we'll identify A, and we define the tangent to be this. It's the side opposite over the side adjacent. So here's A. It's the side opposite, A, over the side adjacent, B. So this is going to be A over B. Okay, so up here, let's find the sine, cosine, and tangent of angle B. Now here's angle B. I had C written before, but I just changed that to B. So we want the sine of angle B. So locate yourself at angle B. So here's angle B. Now, after you do these for a while, you get to know what the definitions are. What is the sine? So the sine of an angle is the side opposite that angle over the hypotenuse. Now look at B. The side opposite is B over the hypotenuse. So this is going to be B over A. Right? This is the side opposite over the hypotenuse. Now, the cosine of B. So locate ourselves at B, and here's the definition. The cosine is the side adjacent to the angle over the hypotenuse. So come up here at B. B is the side adjacent, which is A, over the hypotenuse. So we're going to write this as A over C, right? It's going to be the adjacent over the hypotenuse. And for the tangent of B, so we locate ourselves at B, we look at the definition. The tangent is the side opposite over the side adjacent. So follow it up here. Here's B. It's the side opposite over the side adjacent. So this one is going to be opposite over adjacent. Okay, so in problem number 1, we're given this triangle, and I went ahead and computed these, but let's go through it. So we're given this triangle here. Now what we want is the sine of A. So locate yourself at sine of at angle A. Now the sine is opposite over hypotenuse. Opposite over hypotenuse. So you're here at A, the opposite is 7, hypotenuse is 25. So the sine is going to be 7 over 25. Now what about the tangent? We want the tangent of A. Well, the tangent, that's the opposite over the adjacent. Seriously, if you do a few of these, you'll get to know, you'll remember what these are. The tangent is the opposite over the adjacent. So locate yourself at A. It's the opposite over the adjacent. So we're going to get this 7 over 24. And now we want the cosine of b. So we have to locate ourselves at b. Here's b. And what is the cosine? Well, the cosine, right, the cosine is the side adjacent over the hypotenuse. So the cosine is the adjacent side over the hypotenuse. So we're going to get 7 over 25. And there's our 7 over 25. Now, here in problem number 2, we want to find these trig functions. We want to find the sine of A, the secant of B, and the cotangent. So we need some more definitions. So first of all, here's the definitions that we have so far. But now we have these new definitions. So let's see what we can do here. We have our 3 basic trig functions, sine, cosine, and tangent. And now we're going to define 3 more. These are called the cofunctions. Sine goes with cosecant. Cosine goes with secant, or secant goes with cosine, and tangent with cotangent. Let's see how these are going to go. So here's the ones that we know already. Let's get these. So let's just remember what they are. The sine of angle A is the side opposite over the hypotenuse. So we're going to get the side opposite angle A, which is an A, over the hypotenuse, which is C. Make sense? Here's A. The side opposite is that small a, and the hypotenuse is C. The cosine. All right, the cosine of A. Here we are at A, and the cosine we define to be this. The side adjacent, which is B, over the hypotenuse, which is C. So this is going to be B over C. And then the tangent of A is going to be the side opposite A over the side adjacent to A. So here we are at A. The opposite side is small a. The side adjacent is B, small b. So this is going to be A over B. Now, the cosecant is defined as the hypotenuse over the side opposite. So let's come over here. Here's the hypotenuse C, and the side opposite angle A is A. So we'll write this as C over A. Now the secant of A, right, still here's our angle A, right? The secant of A is the hypotenuse over the side adjacent. So coming back to our triangle, here's the hypotenuse and the side adjacent is B. So this is going to be C over B. And then finally the cotangent of our angle A, that's going to be the side adjacent over the side opposite. So coming up here, here's our angle A. It's the side adjacent, B, over the side opposite, which is A. So this is B over A. So here is problem number 2. Number 2, we're given this right triangle here with sides 1, square root of 3, and hypotenuse 2. And what we want to do is find, down here, we want to find these 3 trigonometric ratios. So we want to find the sine of A, the secant of B, and the cotangent of A. So right up here, I've just summarized the definitions of these trig functions. So let's go ahead and start. So the sine of A. All right, so the sine is the side opposite over the hypotenuse, right? That's the definition. I've got it right here. The sine of an angle is the side opposite that angle over the hypotenuse. So let's come up to angle A. Now it's the side opposite, which is a 1, over the 2. And that's what I've written right here. So I've got the sine of A is 1/2. Now let's get the secant of B. So the secant, all right, let's go to secant. I've written A here, but this could be any angle. So the secant is the hypotenuse over the side adjacent. Hypotenuse over adjacent. So we're looking for the secant of B. So come up to angle B, right up here. All right, now it's the hypotenuse, which is a 2, over the side adjacent, which is a 1. So the secant of B is going to be the hypotenuse, which is 2, over the side adjacent to our angle, which is 1. Right, now this is not angle A, right? This is B, so it's the hypotenuse over the adjacent. 2 over 1, down here, which is just a 2. Now the cotangent of angle A is the side adjacent over the side opposite. So come up to locate A, here's A, it's the side adjacent, which is a square root of 3, over a 1. So it's going to be square root of 3 over 1, which is just square root of 3. And now here in problem 3, we're given this triangle. We're given that the hypotenuse is 3.82, and this side here is 2.36 units. But there's no side given here. This is blank. So we're going to have to find this. So we can use the Pythagorean theorem, right? We've got a right triangle, so it's going to be a squared plus b squared plus c squared. So assuming, this is a leg squared plus a leg squared is hypotenuse squared. So here's a leg. We got that one, 2.36, plus the unknown, maybe this is b right here. That's equal to the 3.82 squared. So I've just run through these kind of quickly. 2.36 squared is this number, plus b squared equals square this. We get 14.5924. So we want to get b squared, so subtract this from both sides. So we'll get b squared is this number. Take square roots, and I got b equals 3. All right, so now we know b up here is equal to 3, so I can put a b equals 3 up there. And now here's what this problem is asking us to find. What is the cosine of a? So the cosine is the side adjacent over the hypotenuse, right? I'm just going back over here to look at our definitions. So the definition of the cosine of an angle is the side adjacent to that angle over the hypotenuse. So look at a. Here's a. Now it's the side adjacent, which is the 2.36 over the hypotenuse. So it's going to be 2.36 over the 3.82, and that's what I've written down here. And when I did that division, I got a 0.62. Now next is the tangent of a. Well, the definition of the tangent of an angle is the side opposite the angle over the side adjacent to the angle. So locate a. Here's a. The side opposite we just found to be 3, and the side adjacent is 2.36. So we're going to get the side opposite, which is 3, side adjacent 2.36. Making that division, I got a 1.27. And now finally here for the cosecant of b, all right, the cosecant. All right, let's follow it up to the definition here. The cosecant is the hypotenuse over the side opposite. Hypotenuse over the side opposite. So we want the cosine of b. So follow it up to the triangle. Here's b. Now it's the hypotenuse, which is 3.82, over the side opposite, 2.36. So hypotenuse over opposite, right? There's our angle that we're looking at. Hypotenuse over opposite. That's opposite b. So it's going to be down here, 3.82, the hypotenuse over the opposite. That division gave me 1.6. So here in problem number 4, we're given this right triangle with these values. So this leg here is 13 units in length. This leg here is 84 units, but we're not given c. But we can find it, right? We've got a right triangle, so how about the Pythagorean theorem? So I did it over here. You can follow along if you can here. 13 squared plus 84 squared is hypotenuse squared. All right, so you follow that. That'll give us that c is equal to 85. So the length of the hypotenuse here is 85 units. And we are asked to find the sine of a and the tangent of b. So locate angle A. Let's do the sine first. Locate angle A. Angle A is right here, and here's our definitions. The sine is the side opposite the angle over the hypotenuse. So here's A. The side opposite, okay, that's A, that's 13, and the hypotenuse, okay, we found that to be 85. So this is going to be opposite over hypotenuse, 13 over 85, and that's what I wrote down here, 13 over 85. So let's now go for the tangent. This is the tangent of B. So let's locate B. Let's put ourselves up here at B. So here's B. And the tangent is defined as the side opposite the angle over the side adjacent to the angle. So we're up here at B. Now the side opposite is B. Now that's 84. And the side adjacent, that's the 13. So the opposite over the adjacent is going to be that 84, right? There's the 84, the opposite, over the adjacent, which is 13. So the tangent of B down here, 84 over 13. Now, problem number 5 is very much like problem number 4, but in problem 5, we're not given A. In 4, we were given A and B, and we had to get C. Now we're given B and C, and we have to get A. But we can do it, right, because we have a right triangle. So we've got a right angle right in there. So let's use the Pythagorean theorem. A squared plus b squared is c squared. Now let's substitute our numbers. A squared, well, we don't know a, so we'll just go with a squared, plus b squared, well, b we're given as 35, is equal to c squared. C is the hypotenuse, and we're given that that's 37. So let's just subtract. Now, we could multiply these out, but why not just subtract this like this, and then do it all at once on your calculator, right? Here's the calculator for it. 37 caret 2 minus 35 caret 2. I got 144, and the square root of 144 is 12. So now we know up here, I'm going to write a here is equal to 12, and b here, we're given that one, that was 35, and c was the 37. So what we're asked for is the cotangent of a. Now, by the definition, right, here's cotangent over here. The cotangent is the side adjacent to the angle divided by the side opposite the angle. So locate A, right? We want the cotangent of A. So you place yourself here at A, and now the side adjacent is 35, the side opposite is 12. So for the cotangent, adjacent is 35, opposite is 12. And then for the cosine of B, locate yourself at B, just plant yourself at B here, and now look at the definition. The cosine of an angle is the side adjacent to the angle over the hypotenuse. So here we are at B. The side adjacent is the 12, and the hypotenuse is the 37. So coming down here, the cosine is the side adjacent, which is 12, hypotenuse, 37. Now here in problem 6, we want to find the sine of A if the tangent of A is 2. So here's all we know. We know that the tangent is 2, so let's just draw a triangle here. Now the tangent by definition is the side opposite. Okay, here's A. It's the side opposite over the side adjacent. Now we're given that the tangent of A is equal to 2. But 2 I can write, right? See, the tangent's given as a fraction, so write 2 as a fraction. We can write it over 1. 2 over 1. So now we know that the side opposite could be a 2. So we'll write a 2 here, right? Here's A. Opposite of A is 2. Side adjacent is a 1. Now, we're looking for the sine of A back here. We're looking for the sine of A. And the sine, we know, by definition, is the opposite over the hypotenuse. So we need to get the hypotenuse. But, we've got a right triangle here, so we can get the hypotenuse using Pythagorean theorem. So again, it's going to be just plugging in, right? Just plug in all these values. You can follow along. But we're going to get to C is equal to the square root of 5. Now, here's what the sine is. The sine is the side opposite. Okay, here's our triangles. The side opposite over the hypotenuse. So we're going to get 2 over the square root of 5. But now, what we have here is a radical in the denominator, and that's not really simplified form. So simplified form, we're going to get the radical out of the denominator. We're going to rationalize the denominator. And we can do that. Let's do it up here. The sine of A is 2 over square root of 5. We're going to multiply it by 1, but the 1 is going to look like this. Take the denominator and put it on top and the bottom. Square root of 5 over square root of 5 is 1. And then when you multiply, the 2's outside the radical, the 5's inside, it'll stay that way, 2 square roots of 5, but square root of 5 times square root of 5, that's the square root of 25, which is 5. So we're going to write, then, that the sine of A is 2 square roots of 5 over 5. Now, this problem number 7 is very much like the last one we did, but we have a cotangent here. So we're given that the cotangent is equal to this number, and what we want to do is find the cosine. So let's draw what we have here. Draw a right triangle, and we're given that the cotangent is this number, and by definition, the cotangent, right, if you're not sure about it, the cotangent is the side adjacent over the side opposite. So we have that, I'll do it down here. Cotangent side adjacent over side opposite, which is this number. Write it over 1 because it's a fraction. Right, and now, let's draw a triangle with what we have so far. So we have the cotangent of A is this over this, but we have to get the length of the hypotenuse. So once again, we're going to use the the Pythagorean theorem. So we'll get a squared plus b squared is c squared. We know this, right, because we know the sides. So I squared those out, added them together, take square roots, and I rounded off here. Now I rounded off like this because the problem gives us 3 decimal places. So I just decided to round our c to 3 decimal places. So we have c is equal to that number right there. So there's our triangle. And we want the cotangent of the cosine of a. Well, the cosine, right, here's the definition, is the side adjacent, right there, over the hypotenuse, right there. So it's the 5.65 divided by the 1.149, making that division. Here's what I got for it. Now, problem number 8 is just like 6 and 7. We're given that the secant of the angle A, the secant of this angle is the square root of 2. All right, now here's our definitions just to remind us. Let's go up here. The secant of A, by our definition, is the hypotenuse divided by the side adjacent. Okay, I've got it right down here in our definitions. It's the hypotenuse over the adjacent. So we're given that the secant is square root of 2. Write it as a fraction, square root of 2 over 1. So the secant is the hypotenuse, so that square root of 2 must be the hypotenuse, and the side adjacent must be a 1, right? We're taking this. The angle A is the hypotenuse over the adjacent. So square root of 2 over 1. Now, we still have to get this value over here, but Pythagorean theorem again, right? A squared plus b squared is c squared. 1 squared, right, there's the 1, plus b squared is this squared. 1 squared is 1, b squared, square root of 2 squared is 2. Subtract the 1, I got b equals 1. So just right up here, I got that b equals 1. Now we have all 3 sides of that triangle. Let's get what we're asked for, which is the tangent of A. And the tangent is defined as the side opposite over the side adjacent. So here we are at A. Locate yourself at A. The opposite is 1. The adjacent is 1. So we're going to get 1 over 1. So the tangent of A is a 1. Now, way up in problem 9, here's the picture we're given. Now this symbol right here, that's a Greek letter theta, T-H-E-T-A. So instead of using A and B, we're just using this Greek letter theta, which is very common in trig to use theta as the name of an angle. So what we're going to have here is that here's our definitions. Okay, now instead of A, we're writing theta. So what we're looking for here is the sine of theta. All right, so the sine of theta, well, the sine, by definition, is the side opposite over the hypotenuse. Now, here's theta. The opposite is y, and the hypotenuse is z. So the sine of theta is y over z. The cosine of theta, well, the cosine is the side adjacent over the hypotenuse. So here's theta. The adjacent is x, hypotenuse is z. So over here, the cosine of theta is x over z. The tangent is opposite over adjacent. So here's theta. The opposite of y, the adjacent is x. So we're going to get y over x. Now the cosecant, if you don't remember it, it's right here. It's the hypotenuse over the opposite. So we're over here, up here right at theta. Here's theta. Now the hypotenuse is z over the opposite, which is y. So here's the hypotenuse over the opposite. Now the secant, here's the secant. It's the hypotenuse over the adjacent. So the hypotenuse is z, the adjacent is x. So the secant over here is hypotenuse over adjacent, z over x. And then finally the cotangent, all right, here's our definition of cotangent. It's the adjacent over the opposite. So here we are at theta. The adjacent is x. The opposite is y. So we are going to get way over here, x over y. Problem number 10 gives us this right triangle here with these sides. Hypotenuse is missing. And we're asked for the sine of A, the cosine of A, and the tangent of A. Now, in order to get these, we need to get the hypotenuse. So Pythagorean theorem coming up, right? A squared plus B squared is C squared. So how about 33 squared plus 56 squared? That's equal to C squared. I just did it directly on the calculator. I typed in 33 caret 2 plus 56 caret 2 equals C squared. Add these, and these, it's automatic on the calculator. I got 4225. And then what we need is really the square root of 4225. That's going to be the square root of C squared. So I'm getting C is equal to 65. And now let's get the sine of angle A. Now the sine turns out to be, okay, it's the opposite over the hypotenuse. Opposite over hypotenuse. So this is going to be 33 over 65. Right? This is the opposite over hypotenuse. The cosine of A is the adjacent over the hypotenuse. So this is going to be 56 over 65. And then the tangent of A is the opposite over the adjacent. Opposite over adjacent. So this is going to give us 33 over 56.